In this lesson, we're going to take what we learned about common logs and we're going to apply it to solve exponential problems that we weren't able to solve before. Our goal is to get to a problem like this where we have two bases that are not alike and we can't get them to be the same base, and to solve those problems where before we could, if they could get to be the same base, now if they aren't the same base, we can use logs to solve that. So that's our goal. Our objective is to use logs to solve problems. Let's back up just a step and talk about problems that we have done before with exponentials and with logs, to review just a little bit first, and then we'll get to the more difficult problems. So first of all, a problem like this, where if you've got 2 to the 10x power equals 32 to the x plus 4, if I've got two of these where I can get them to have the same base, that's the best way to solve it. So I'm going to get these to both be base 2. So what I'm going to do is take this problem, I'm going to leave the 2 to the 10x problem here, and on this one I'm going to make that 32 into a 2 to the 5th. Now I'm going to simplify the exponents here, leave the 2 to the 10x. On this side it's going to become 2 to the 5 times x plus 4, so 5x plus 20 power. Now, once you have the same base on both sides, you can take the two exponents and set them equal. So the 10x is equal to 5x plus 20. Subtract 5x from both sides, you get 5x equal to 20. Divide by 5 and you get x equal to 4. So if you can get the same bases, set the exponents equal and solve. This next one here, to solve this one, what you have is you have two logs with the same base on both sides. Just like these had the same base for the exponential, notice that the base of these logs are the same. Log base 10 of 6x equals log base 10 of 42. Now just a reminder, if it's log base 10, that's called a common log. I can get rid of listing the 10 there, and that is implied to be log base 10 if there's no base listed there. So if the bases are the same on both sides, you can set the inside parts equal to each other. So 6x is going to equal 42. Just divide both sides by 6 and you get x equal to 7 to solve it. Now those are the problems we've done where you can get the base to be the same. We're going to go ahead and now set up problems where you can't get the base to be the same. So we're going to also, just as a reminder, just since there's a little bit of review here, here's our 3 rules of logarithms. I'm really going to lean on this rule down here. The third rule says log base b of n to the r. You can take that exponent of r, move it down in front, and it becomes r times log base b of n. What that tells me is anything that has a variable in the exponent, if I take the log of both sides, I can bring the variable out in front and it's no longer in the exponent. So I'm going to take advantage of that. So let's start with the simpler problem. Before I get to this difficult one, I'm going to start with 4 to the x equals 19, and I'm going to solve that problem. Now notice I can't get these bases to be the same. So what I do is, if I take the log of both sides, now that's just the common log. I'm not listing a base, so it's the common log. Notice I can use this rule that says if you have an exponent there, you can bring it down in front. So I'm going to bring that x down in front of log of 4 equals log of 19. And now I can divide both sides by log of 4. And what I get is x equal to log of 19 over log of 4, which we can do on our calculator. So you get your calculator out. Now you can use that log key that's on the middle of the left-hand side there. That's the common base, the common log there. Log of 19, make sure you close the parentheses on it, divided by log of 4. And what I get is about 2.123963757. So I'll tell you to round to it another number. Let's say we just round that to 2.123. 124. Okay? All right. So that's the basic idea of how you do these problems, is take the log of both sides, and that will get you the exponent out of the variable out of the exponent. Let's have you try this one. Pause the video and see if you can solve this one using that technique we just talked about. Now that you've tried it, let's go ahead and do it together. So let's take the log of both sides. The advantage of doing that is that can get the variable out of the exponent. So I'm going to bring that exponent, like we do here, that exponent variable, bring it down in front, and it's going to be x times log of 3 using the third rule there. I'm going to divide both sides by the log of 3. And when I grab out my calculator here, I'm going to take log of 15. Make sure you don't take 15 divided by 3. Remember, this is not where you have 15 divided by 3 on the inside. This is a log of 15 divided by log of 3. So there's 2 logs already. So it's not using that rule. Make sure you know the difference between those two. And so I'm going to take log of 15, close my parentheses, divide by log of 3, close the parentheses, and I get about, I'm going to round to 2 decimal places, so about 2.46 when I round that. Okay, so there's a way to do it to get the variable out of the exponent. Let's use that to solve this problem. So to do this one, what I want to do is take the log of both sides. So I'm going to take log of 6 to the 3y equals log of 8 to the y minus 1. Now I can bring the exponents out in front. Now here is a hint. I'm going to actually figure out what the log of 6 is and the log of 8 is, because I've got a log on both sides. So I'm going to use my calculator. I'm going to do it to about 4 decimal places. So I'm going to do log of 6, because I brought the 3y in front of it. So log of 6 is approximately to 4 decimal places. Let's see here, I get 0.7782. Okay? All right, I'm going to do that on the same thing on this side. Take log of 8, and I get about 0.9031. Now I'm going to distribute, here I'm going to just multiply it by the 3. So I'm going to take that 0.7782 times 3. And so on this one I get 2.3346y. Still have that y there. Distribute this through and I get 0.9031y. And then minus 1 times that is 0.9031. Now let's bring this over to this side by subtracting it from both sides. So I'm going to take this 2.3346 and I'm going to subtract this 0.9031, and I get on this side 1.4315y, because I brought the y's together. On this side I have negative 0.9031, and now I'm going to take that negative 0.9031 and divide it by this 1.4315, and that will get me what y equals. Y equals negative 0.63, I'm going to say 09, I'm going to round it to 4 decimal places. There's my answer for doing that. So what we were able to do is take a problem that we couldn't do before because you couldn't get the bases the same, but you have variables in the exponents, and we can solve it now by taking the common log of both sides, bring the exponent down, which has those variables, and then solve it once those exponents are now down in front and you got the variables where you can solve them.